This is an example of a problem that involves the coefficient of friction that we did in class on December 1st or November 30th. So in this problem, we have a crate that's accelerating across the floor, and we are supposed to determine how much acceleration that is. Let's start by drawing a free body diagram. So we are assuming it's accelerating to the right from that rightward force, and I'll just call it F applied. Of course, it would have a force of gravity on it, and we'd be able to find that from the mass. It's not accelerating up or down, just horizontally. So we know that the normal force from the floor should be the same size as the force of gravity, just up instead of down. And then because they're asking they're giving us information about kinetic friction, then we know there is some. So let's just draw an arrow that's smaller than the applied force, and I'm labeling that force of friction, comma, kinetic, because that's the type of friction we have here because the crate is moving. Okay, so we have here the rightward force. They do tell us the magnitude of that is 302. And they tell us this is the mass here, 28.6 kilograms. And then they tell us the coefficient of kinetic friction. So notice this number has no units. Okay, this is called mu k. It's basically a stickiness factor that accounts for the surface of the crate and the floor. Okay, so we are trying to find acceleration, and this is going to be one of our longest problems. It's definitely multiple steps. So let's kind of plan out how we're going to get acceleration, and that's the end, okay? So in order to get acceleration, I would use Newton's second law, which means I need to know the mass and the net force. And I know the mass, but I don't know the net force because some of these forces, like I don't know what force of friction is yet. So how can I add up all the forces to get the net force? So that means that I'm going to have to find net force first. And since I don't know all the forces, I'm going to have to find those. For instance, I would like to know the force of friction because I'll have to have that in order to add it with the applied force. Then I go looking at my formula sheet and I see that in order to find force of friction, I have to know the coefficient, which I do. That's this one, right? But I also need to know the normal force in order to get that, which means, oh man, I've got to find normal force. Now, they don't give that to me either, but I do know how to find force of gravity. And because force of gravity and normal force are canceling each other, if I can find force of gravity, then I'll know what the normal force is. So this is like a 4-step problem. Okay, so first step, and you could almost always do this, is to find force of gravity. That's really easy. Let's do that first. So Fg is mass times G on our planet. So we're going to use our 28.6 kilograms times negative 9.8. And why don't you get your calculator out and kind of follow along with me here. Let's try to make this skinnier. Okay, so if you do 28.6 times negative 9.8, we get negative 280. Let's keep 3 sig figs. Okay, so that's down here. Which means then, since it's not accelerating upward, that the normal force would be just that number, only positive, same magnitude. Okay, so now I've got that and I've got that. I can add this here if I want to. Okay, next step is to use the given information to find force of friction. So let's do that. Force of friction is equal to the coefficient of friction times normal force. So that I can plug and chug because I know the coefficient and I now know the normal force. Let's do that multiplication. And I get 210, three sig figs. Okay, now here I should point out that on my picture, I have force of friction drawn to the left because the crate is moving right. And my equation tells me that it's 210 newtons, but really, I better make that negative. So I'm going to put that up here, but I'm going to note that since it's left, that I might need to make it negative. And that's just the fact that the formula doesn't really account for which direction you've drawn the friction arrow in. Okay, so we got force of friction. Next step is to find net force. Okay, so net force is equal to the sum of all the forces on the diagram. Now technically, I should add up all four of them. But, I mean, is it okay if I know normal force and gravity cancel each other, so I'm not even going to put them on here. You could if you wanted. But they point up and down, and that gets kind of confusing. Let's just do the sideways ones. So we have force of friction plus force applied. So then I'm adding my negative 210 plus the 302, and I get 92. Following the addition rule, I'm only allowed to keep to the ones place, so I'm stuck with just two sig figs now. Okay, and then I've got my FNet done. So then the last step is to use that to solve for acceleration. So let's say now Newton's second law, F net over mass gives me acceleration. So 92 newtons, which is supposed to be positive. That means to the right, and I know it's accelerating to the right. Divide by the mass of 28.6 kilograms. And I get 3.2 meters per second squared. Okay, so problems for homework are not exactly like this. They're all a little different. They ask for something different, or they give you something different. So it's like a puzzle, and I suggest always drawing the free body diagram first so that you know which pieces of the puzzle you're missing and which ones you can find right away.